start your report without much longer delays. I also see that the reviewing team has already noted who is the reviewer in this final stage for today and for the IYNT 2021. New Zealand, you're not reviewers, you're reporters now. I see that. Yeah. Okay, so we just note that your reporter is Charlie. And we will ask the opposing team to please note. Okay, yes, they have already noted it. Who is the opponent in this stage? Okay, let me restart the clock. Okay, Team New Zealand, please be ready to start your report as soon as you can. If our break would be of 10 minutes, we would have maybe...
Can you guys see the slides?
You see it? I'll put in mine. Okay.
Hold on.
Everyone just mute your other.
Hello? Can you hear me?
Yes?
Can you see the presentation?
Can hear you properly, but we can see the presentation here from yeah.
Okay. May I start?
Just wait a couple of
I
seconds.
can't see the presentation.
Say again, please.
We cannot see the presentation.
We cannot see the presentation. Okay, Team New Zealand, please try to turn off the stream and launch it again. Maybe this would help. And in the meantime, I also ask the jury members to please confirm that no one is complaining and everyone can see the slides. In case someone cannot, then we can ask.
No,
Okay. Yes. Okay. Is there anyone now who is not able to see the slides from our last reporter today? Oh, no one is complaining. So, Team New Zealand, I invite you to please start your report as soon as you can.
Okay. Hello, everyone. I'm Charlie Chen, and I'm from the New Zealand team. I'll be presenting problem number 2, liquid layers. This is the problem statement. Water and vegetable oil do not mix and form 2 layers in a beaker. It is possible to fill the beaker with many more layers of immiscible fluids. How many layers can you obtain? Investigate this motion of interface if the beaker is disturbed or shaken. So just to clarify, immiscible means substance that form a heterogeneous mixture, meaning they don't uniformly mix, and the substances will separate if left to stand. Fluids are liquids and gases, but the topic is called liquid layers, so I assume it only means liquids. So together, immiscible fluids basically means liquids that don't mix. So density layers are layers that form because of the difference in density and the careful placing of liquids on top of another liquid. Density is the mass per volume unit. The higher the density, the heavier the substance is. Water has a higher density than oil. This is why it is at the bottom and oil is at the top. We tested ourselves to see if density layers can form layers. We used dishwashing liquid and water to form 2 layers. After 1 week, as you can see, the water and the dishwashing liquid mixed. So, from the experiment, showed that the density layers can only form a temporary layer, so they do not count as immiscible layers. This means there's something else that's separating water and oil, which is the difference in polarity. There are polar substances and non-polar substances. Like dissolved like, meaning substance with the same polarity mixed with each other. So, polar liquids will mix with polar, and non-polar will with non-polar, and polar doesn't mix with non-polar. So, polar substances are when the molecules net polarity. This, which simply means the molecules has an overall positive charge side and a negative charge side. The polar molecules attract each other because they're opposite in charge. This strong and permanent force of attraction between two polar molecules called the dipole-dipole force, which causes them to mix. Non-polar substances are when the molecules don't have or have a very little net polarity, which means there's basically no positive or negative charge side, so the molecules are basically neutral. However, due to the random position of electrons can sometimes simultaneously come together to one side, meaning non-polar molecules can have a temporary weak net polarity, and they induce their neighboring molecules to become polar as well. This weak attraction generated from the non-polar molecules is called the dispersion force. So, polar molecules and non-polar molecules do not mix. This is because the dipole-dipole force of the polar molecules is stronger than the dispersion force, which means it's easier for polar molecules to stay together rather than spending more energy to mix with the non-polar substance, so the process won't happen. So, for my method, this is what I think the result should look like. The beaker should be filled with as many layers as possible, with the adjacent fluids being immiscible, including oil and water as 2 layers. For this to work, fluids must be alternating polarity so they don't mix, and have a density gradient from heaviest to lightest, so that the liquids with the same polarity won't be adjacent to each other and mix. Here's the research I did with all the polar and non-polar liquids with their density. Dishwashing liquid in this case is an amphiphilic liquid. These are the fluids I was able to access to, and the density are from my own testing results. And here's a graph that represents my data. I tested the density by putting the measuring cylinder on the scale and set it to 0. Then I fill the measuring cylinder up to 10 ml for each fluid and record down the mass. Finally, I calculate the density of each fluid using the formula from earlier, mass divided by volume, and compare the research value to check if it is valid. Here's the results I got in the research values, which is pretty valid. So now I got the data I need. I put 5 layers in the tube and waited for 5 days. In the end, all layers stay separate except for the dishwashing liquid and the water. They mixed. This is expected because dishwashing liquid has a polar end and can mix with the water. This means dishwashing liquid does not count as a layer. Next, I swapped the dishwashing liquid with honey, and I waited for 1 day. In the end, all the layers stay separate again, but the honey and the water mixed. This is also expected because water and honey are both polar. This means honey does not count as a layer either. So in the end, I was able to obtain 4 layers. So now I observed interface motion. Interface is the boundary between 2 liquids. I put the adjacent layers together and mixed them for 30 seconds. Then I observed the motion of interface. What I found out is that after being shaken, the interface would disappear and the liquids form an unstable motion. Then slowly, the interfaces reform from the bottom and slowly upwards as more of the denser liquids join together at the bottom. Gravity. If left to stand, the liquids will separate eventually and the interface will be back to its original place. Through observation, I found out that the speed of the interface moving got to do with the density difference between liquids. The interface of water and canal oil is the second fastest. This is because the difference in density is quite big, which is 90 kg per meter cubed, so the liquids can separate pretty quickly. The interface of canal oil and ethanol moves the fastest. This is because the difference in density is very big, which is 130 kg per meters cubed, so the liquids will separate very quickly. The interface of ethanol and kerosene move the slowest. This is because the difference in density is very little, which is 30 kg per meter cubed, so the liquids will separate very slowly. So, in the end, I was able to obtain 4 layers: water, canal oil, ethanol, and kerosene. This was done by carefully placing each layer on top of a previous one and making sure they don't mix across layers. Because of the density difference between each layer, the layers won't change order and will stay separate. So, I think there can be many more layers created, But one of the main limitation, I think, eventually comes down to density, as the density can't get infinitely heavier or lighter. So, in conclusion, I was able to obtain 4 layers: water, canal oil, ethanol, and kerosene. I have explained the theory of why this is possible, covering polarity, density, and miscibility of fluids. Using this theory, I've also provided a method of creating immiscible liquids, of immiscible layers. Using this theory, I've also identified that the density is one of the main limitations of the number of layers. I've also found out that the reforming of interface is from the bottom to the top, and the speed of it depends on the density difference between two liquids. And here's my bibliography, the end.
Okay, thank you very much indeed for your report. Thank you very much. We now move on to clarifying questions from the opponents, please. Clarifying questions.
Hello, can you hear me?
Yes, I can.
Okay, I've got some clarifying questions for the opponent, such as I saw that you were missing your theoretical model. How can you calculate what's the maximum number of layers that you can put one above another so they don't mix?
Pardon? Can you explain? Can
Can
you
you
say it
repeat?
again?
Oh, to ask you again. Yes. There should be a theoretical model that explains how can you calculate the maximum number of layers that you can stack one above another. But do you know how you can calculate it, or what was your number of layers in the problem?
So experimentally, I got 4, but
And do you think you could have stacked more, one or above another?
you can stack a lot more. However, there's some limitations, which I stated. One of them is density.
Okay, and I saw in one of your experiments that you shake the substances from the beaker. How did you shake them? Did you disturb them a little bit, or what was the motion of
Oh
shaking?
yeah, okay. So I stirred it for 30 seconds for each of them, and I keep the force constant as possible.
And how did you shake them? With
I,
what object? With your hand or with a mortar or something?
sorry, I stirred them with a stirring rod.
All right, and I saw that you had some amphiphilic molecules. Can you describe them a little bit as in the project they were just mentioned, not defined?
Pardon? What molecules?
Amphiphilic molecules.
Oh, amphiphilic molecules are when the molecules, one end of the molecule is polar, while the other end is also non-polar. So dishwashing liquid has a polar end and a non-polar end. That's why it's able to mix with water.
Oh, all right. Thank you. And in the theoretical part, when you explained the polarity of the molecules, you were speaking about dipoles. And I don't think you mentioned the dipole moment. Do you know what it is? Can you describe it a little bit, the dipole moment?
The dipole moment. Okay, so basically, the more electronegative, the more electronegativity difference between atoms
Oh,
together.
all right. Okay, okay, I understand. So you know.
Okay. We're
Okay.
out of time. We're out of time, and now we have preparation time for the
Right.
opponent, please. Okay, we're out of preparation time for the opponent, so we invite the opponent to please start your opposition.
Okay, can you see my screen?
Yes.
Yes.
Okay.
We can see it.
I'd like to start. Hello everyone, my name is Amalia, and today I'm gonna present mania limitless in problem number 2, liquid layers. The task of the problem was to determine how many layers can we obtain in an experiment, and to investigate the motion of the interfaces and if the beaker is curved or shaken. And the keywords for the problem are immiscible fluids, polar or non-polar molecules, and this should be in the theoretical part. Then numerous layers are in the interpretation of movement in the experimental part, and we shall talk about the relevant parameters. This is the outline of the reporter. The introduction was well done, but the theoretical explanation or the setup and experiments were good, but the comparison needed improvement. This is the theoretical. In the theoretical part, let's talk about some strong points, such as the chemical explanation of the immiscible fluids. It was the chemicals were explained very good, and there has been explained the relation between the polar and non-polar molecules with the forces responsible for the experiment. And here are some weak points. They didn't specify polarity, that polarity is a spectrum, that dipole moment explanation is missing, the theoretical model is missing. They didn't calculate theoretically how many layers that could be created in an ideal environment. The hydrogen bonding theory is not present. They mentioned the amphiphilic solution but didn't define them in the project. Didn't specify that the short nonpolar molecules dissolve in the polar ones, and they didn't have a clear structure, such as hypotheses or conclusions. So for the theoretical part, I'm gonna be giving 3 points out of 5. Then we have the experimental part with strong points. The experimental setup was well detailed with all the chemicals or all of their densities, and it was shown clearly how the experiment was made. There was a variety of substances used, and they presented very well, as I said before, the substance properties. Then we got some weak points, such as the substances from the table were not well specified and did not work for this experiment. There were some wrong data about ethanol. There are some possible errors in mixing, as the mixing was done by hand, as I understood from the reporter. The motion is not investigated sufficiently, and there should be a difference between shaking and disturbance. The preparation of the apparatus is missing, and the motion of the beaker is uncontrolled. As they said, they mixed it with their hand. And this is my presentation, and I'd like to move on to the discussion topics, if it's all right.
Okay, if it's done with your statement, then let's thank the opponent for your opposition. Thank you for explaining all points. And now we move on to the discussion between the reporter and the opponent, please.
All right.
Hello.
Hello. First of all, I'd like to talk about this dipole moment, as I believe it's very important for the experiment and for the substances so that they can be explained well. But we talked about this, but there is no theoretical model of the maximum number of layers. And when I asked you if you have a formula for this, or if you found a formula, you didn't really answer my question. So do you have a formula for the theoretical model of the maximum number of layers?
Can you hear me?
Yes.
Okay. There's no formula that can calculate the maximum number of layers, because there's just too many factors to consider.
All right. Okay. And okay, let's continue. Later, I'd like to talk about the motion of the beaker that, as I understood from my clarifying questions, is uncontrolled. Can you repeat one more time how did you motion the beaker and the substances inside, and what was the result of the disturbance?
Okay, can you see my slides?
No, 1 second. Your slides? No, you didn't present anything.
Okay, I will share it again. So basically, I put two liquids together and I mix them with a stirring rod, and I try to keep the force consistent, and I mix 30 minutes for each for 30 seconds as when I did the test. And yeah, so basically the motion is that they start out with no interface, and the interface form again at the bottom, like I explained in my presentation. And slowly the interface moves up, and then eventually
Okay, I understand. Okay, thank you. Let's move on to the next topic. 1 second. Where were we? Do you find the difference between shaking and disturbing? And did you shake the beaker or did you disturb it?
I disturbed it by stirring it, and it doesn't really matter because the question says with disturbed or shaken, so it doesn't really matter which way you do it.
Well, I believe that it does, because if you have shaken it with your hand, it is an uncontrolled motion that may affect the final result. And
Why do you need to control the motion? The purpose of it is to mix it, so the end result is the same. It doesn't matter how you're just trying to mix it. So
yes, but maybe mixing it by an uncontrolled motion, they would mix differently.
okay,
Together.
yeah, I get what you mean. I get what you mean. However, I think that no matter what you do, shaken or disturbed, the result is the same, so it doesn't matter.
I understand. Moving on, how did you insert the substances in the beaker? Did you just pour them by hand, or how did you insert them?
I used a pipette.
Well, yeah, that's good. You could have used also a syringe. That would have been probably easier. And I'd like to talk about the environmental conditions of the experiment. What was the temperature outside the beaker?
Oh yeah, so as you can see on my slides, I have a thermometer at the end, at the top of the experiments, which is the room temperature is 22 degrees.
Yes.
And I
Yes.
keep
After you said before it's 22 degrees, did you control it so it would
yes,
be
I did.
same for the whole experiment?
Yes, I did. I left the air condition on.
Okay. And one more time, can you explain the dipole?
Okay, so basically, you can have a stronger dipole and a weak dipole. It all depends on how more the electronegativity difference between the atoms bonded together.
The dipole moments occur when there is usually a separation of charge, and they occur between two ions. And yes, how many times did you repeat the experiment?
Okay.
5 times.
Okay, okay. We're out of time. We're out of time now. Thank you very much. Thank you very much. And now we can move on to the next phase, which is clarifying questions from the reviewer, please.
Hello, can you hear me?
Yes.
Okay, so to the reporter, first, in what order did you place the different layers in the tower?
Pardon, are you asking me?
Yeah, to the reporter.
Can you say that again?
In what order did you place different layers of the tower?
So I explained it in my slides. So it was water, canal oil, ethanol, and kerosene from the heaviest density to the lightest density.
Okay, thank you. And can you measure quantitatively the mixing of the layers? Do we have a way?
It doesn't matter.
Okay. Another thing I would like to ask is what will happen if we heat the tower? Do you have any idea? Do you have any idea what will happen if we heat the tower?
So as the temperature increased, the density will reduce. However, because you heat the tower, so all liquids will, the density of all the liquids will reduce will reduce.
Okay, thank you. To the opponent, you asked about methods of distortion of the tower. Can you suggest different ones from the one used by the reporter?
Yes, using a motor to shake the beaker in a controlled motion so that it mixes perfectly.
Okay, thank you. To the reporter, do you think that surface tension of the liquids matter?
The what?
The surface tension of the liquids, does it matter?
Yes.
Okay. And do you think it is possible for a liquid to disappear from the tower?
A liquid to disappear? No.
Okay. Well, thank you. I think that was it for me.
Okay, thank you very much. We'll now move on to the preparation time of the reviewer, please.
In the meantime, can the reporter please send the presentation to the text channel?
Okay, I'm just echoing it that one of the jurors asked the reporting team to please drop your slides into the text channel.
Can you see me and my screen now? I can't hear you. I think you're muted.
Yes, I was muted. I was asking someone to confirm, please.
Yes, Romania can see the screen and can hear you.
Yeah, same for me. So apparently everything is working.
Okay, so I'll start my review. I'm Dinti Vasileva from Team Bulgaria, and I will be reviewing the problem liquid layers. So, as the problem was stated, we had to see if it is possible, how many layers can we put in of immiscible fluids, and we have to investigate the motion of the interference if the beaker is disturbed or shaken. I think that the problem was partially fulfilled. Then, for the overview, I think the theory of the reporter was very good. The experiment was average, and the results need some improvement. There was agreement between theory and the experiment, which was average, and the conclusions need some improvement. So, for the reporter, I like that he defined the main parameters: immiscible fluids, density, and polarity, and their theoretical explanation as to why different polarity layers remain separated. But what I didn't agree with is the lack of experimental method. They did not have a hypothesis and sources of error. They did not account for surface tension as a reason for separation of the layers. There was no differentiating between layers only due to polarity. Density differences were not observed. There was insufficient number of liquid layers obtained. Only one method for distinguishing the tower was shown, and there was no uniform force applied for stirring the mixture. They didn't show any experimental setup, and there was a lack of quantitative investigation. There were no clear conclusions and a poor explanation of the amount of layers obtained. They claimed to be infinite, and they claimed the layer cannot evaporate from the tower. So, for the opponent, he asked many important questions, such as the method of shaking of the tower. He highlighted the importance of constant mixing and not controlled one, and suggested methods that reporter hadn't mentioned. But he didn't prioritize the questions, didn't focus on the experiment, but on theoretical questions. He didn't address all the missing points in the report and addressed experimental setup, which was missing in reporter's presentation. He claimed that the used substances were enough and I don't think the hydrogen bond is such a relevant parameter in this. So the discussion, the optimal height of the tower was discussed, the motion of the shake beaker and the repetition of the experiment, but there weren't clear answers from the reporter, the questions weren't prioritized, and the opponent clarifying questions in the discussion. There is a difference between the used method of disturbance since it will probably reduce different results. As for the missing point, there they could have established more different methods to test the stability of the tower, investigated the evolution of the tower for a prolonged period of time, not 5 days but months, and they could have quantitatively measured the mixing of the layers, and they missed sources of error. As the clash, the point of discussion was the motion of the beaker. The reporter claimed there was no difference between shaking and stirring, and I agree with the opponent, and there is a difference. So thank you.
Thank you very much indeed for your review. Now we move on to concluding remarks by the opponent, please.
So, can you hear me? Yes.
Yes.
First of all, I'd like to thank the reporter and the reviewer for the chat. But there are some things I'd like to mention about the project, such as the formula that's missing, and there is a very easy formula that should be searched, and the maximum numbers of layers possible if the placement is close to perfect should be 87. The reporter didn't insist on the intermolecular forces that are pretty important. They never mentioned the dipole moment in the experiment, and as the reviewer said to me in my errors that I said they said the hydrogen bonding is not important, but it is because it helps the water from mixing with non-polar liquids, and it should be mentioned. And lastly, the experimental part was poor. They could have done more experiments with more layers shown. This is it. Thank you very much.
Okay, thank you very much for your concluding remarks. And now we have concluding remarks from the reporter, please.
Can you hear me?
Yes.
Okay, first of all, I would like to thank everyone here for my presentation and for their participation in the last round of IYNT 2021. So in my report, I've explained what the immiscible fluids are, and using this knowledge, I've come up with a method to stack immiscible layers. And I was able to obtain 4 layers experimentally due to the lack of liquids I was available. I've also identified that density is one of the main limitations on the number of layers. I've also found out that the reforming of the interface is formed from the bottom to the top, and the speed of it depends on the density difference between 2 layers, which was what I was supposed to investigate. And generally, I disagree with the opponent and the reviewer as the method of disturbing is not relevant since the end result is the same, which is basically mixing the liquids. So in conclusion, I've covered the problem in the deep and extent and provide valid results, methods, and explanations. Thanks.
Okay, thank you very much for your concluding remarks. And now we move on to questions from the jury members.
May I ask?
Yes, please.
All right, the question to the opponent. Why do you think it is so important to control the conditions of mixing? So,
I believe it is important because by mixing them by hand, it is an uncontrolled motion and the mix could not be perfect. But by mixing it with
what do you mean by mixing it perfectly?
to stir it, but with a motor that has controlled moves, and it's perfect.
All right.
Okay, Mikita, I see you have a next question.
Yeah, the question to every member of this fight, and the question is that we have 2 liquids, for example, non-polar and polar. And can we mix them in some way to obtain some stable emulsion? First answer reporter, then opponent, then reviewer.
That's a very nice question, Mikita, but according to the IYNT regulations, I suspend this question because exactly that is not allowed. So please ask a specific question to the reporter, a specific question to the reviewer, not the same one, and a specific question to the opponent, please.
Okay, then that is question to reporter.
Okay, so you can use yes, emotion is possible using an amphiphilic, as I explained. An amphiphilic has both a polar end and a non-polar end. So by using an amphiphilic with a polar and a non-polar, the polar end will with the polar end, and the non-polar will mix with non-polar. Therefore, the amphiphilic can cause a polar and the non-polar mix together and stabilize the emotion.
Thank you.
Thank you. Further questions, please?
May I? From the reporter, how can we make the layers more resistant to tension, to mixing, to shaking, to anything? How can we make them more resistant, more stable?
Well, we're not sure, but you could try more thicker layers as it is harder to mix them.
Thank you. From the opponent, you mentioned perfect mixing. I'm just asking again. I know a jury mentioned that before, but you know what a perfect mixture is? Something that is mixed perfectly.
Yes, it's a homogeneous mix. Sorry.
No, when I shall not mention, but it's a solution. They are immiscible. They are not solutions. Thank you.
Okay.
No,
okay.
they are not going to be perfectly mixed. It's an emulsion that later on, because of the layers, polar and non, are going to separate.
So they can't be perfect. Thank you. I have no more questions.
Okay, I see that Alexander, you have a question to the reviewer.
Please, dear reviewer, can you suggest an improvement of setup experiment for measurement or another things?
Well, I would suggest for an improvement, maybe for disturbing the layers, you could put a pill which is one of those effervescent pill, and it will disturb all the layers from the bottom to the top. I think that would be an interesting one. Another method I would suggest is heating the tower, because that would cause differences in the layers too. Yeah. Anything else you'd like me to suggest?
Thank you for all.
Yeah, okay, okay. Any further questions, please?
The question to the reporter. I wonder about the exact effect of heating the liquid. So, what will happen to the densities, and will they still be immiscible?
It is outside the scope of our investigation. But however, when you heat it, the liquids will heat up, and if you heat it a bit more, it will evaporate into gas.
Before the evaporation. So I really wonder what is more important, the density or the polarity in your experiment?
So they're both important. So polarity is what makes them stay separate. However, if you want stacked layers, then density is another factor on top of that to create layers.
All right.
Okay. Well, apparently there are no further questions from the jury members. So I thank all jury members for your questions and all teams for your answers. We now move on to the grading phase, and I will collect the grades from all jurors. And as always, I will write them down in our official protocol, and then we'll have time to discuss these grades and comment on them. We are now 1 minute behind the schedule, but when we are done, apparently the delay will be at the order of 10 minutes. So we want to be reasonably quick because we need to have some break before the closing ceremony. We're still waiting for the grades from one of the jurors. So Dina, when you are ready, please send us your grades. Dina, please send us your grades. Dina, can you hear us? Can you hear us now? Okay, so one of the jurors is now in the room. We are waiting for her grades. Dina, please send us the grades as soon as you can. But in the worst case scenario, if Dina has major connection issues now, it would probably mean that she was not able to hear last parts of this stage. I hope this is not the case.
Ilya, can you hear me?
Yes, yes. Would you please send us your grades? I know that you had some connection issues in the beginning, but we need your grades. Please send them to us. Okay, all jurors are now ready. So I have just submitted the grades to our scoring commission because they need these grades as soon as only possible. And I'm now ready to announce these grades. To the reporter, Ilya, 16, Nikita, 16, Dina, 17, Kudus, 18, Nicholas, 17, Raman, 9, Alexandra, 10, Ahmad Reza, 19. To the opponent, Ilya, 15, Mikita, 16, Dina, 16, Kunduz, 16, Nicholas, 12, Raman, 17, Alexandra, 15, Ahmad Reza, 14. To the reviewer, Ilya, 9, Mikita, 9, Dina, 8, Kunduz, 8, Nicholas, 7, Raman, 9, Alexandra, 6, and Ahmad Reza, 7. Thank you very much for your grades. We now move on to the phase about justification of these grades. The reporter, Raman, your grade was the lowest one. It was 9. Okay, thank you very much for these comments. Thank you very much, Raman. At the opposite end of the spectrum, we had several jurors giving the grades of 18 and 19. In particular, Ahmad Reza, your grade was the highest one. It was the grade of 19. Would you please comment on your 19?
Well, this report for me was really hard to mark. I think you saw that I 3 times changed my mark for it from 15 to 19 because they didn't mention things such as surface tension enough, and they didn't explain polarity enough, and I wasn't really sure what mark to give. But when I asked them about to make the layers more tension resistant, and they said something that led me think that they realized something. They just didn't do it based on a recipe and gave the picture. At least they put some thought on it. They know the mechanism, and yeah, that was the reason that I gave them the mark. I changed 4 marks from 15 to 19.
Okay, thank you very much. We had also quite many jurors giving the grades in between for the report. With the opposition, the single lowest grade was 12 from Nicolos. Would you please comment on your 12?
So I would like to comment on all the three performers. So about the report, I think the report lacked too many things, both in the theory and I quite didn't like the experiment. So there were many points to discuss, and I think that the opposition should have been much more impressive. I have put 1 point for the reporter in defending their solution, and I think that with the right opposition, I should not have put such a high mark. The I really didn't like the questions. I don't think they were sharp enough or challenging for the reporter. And oh, that's it, because the report missed so many things that the reporter should have been much more impressive.
Okay. If we look at the opposite end of the spectrum, Raman, your grade for the opposition was the highest one. It was 17. Okay. With the review, Alexander, your grade was the lowest one. It was 6 for the review.
I think it was not suggest the useful improvement of increase the solution or understanding. It was a decent review. It would be better. Also, there are some some sensible comments, but for example, there are too much empty space instead of useful information in presentation. That's why my 6th grade.
Okay, good. This is clear. My grade was 9 for the review. Basically, I think this was a concise and clear review. And the reviewer, you have addressed many important points and very valid points in the report, in the opposition, in the discussion, and the way how you presented and summarized this stage was clear. And I think that on this scale, 9 was an appropriate grade. Mikita, you also gave a 9 for the reviewer, and I think you have some comments in general about this fight.
Yeah, I think the reviewer worked hard. The review was concise, was consistent, and reviewer insisted on some points that were essential for our solution for understanding this topic. But mostly, I'm dissatisfied with the solution given by reporter because, as for me, it looked like, oh, we took some liquids and we mixed them because we were told so. I lacked some formulas. Yeah, there are some formulas that you can illustrate something by these formulas. And if you say that we only obtain the unstable emulsion if we mix two liquids, it's false. We can obtain some kind of stable emulsion, and that was part of confusion for me. But you all have done a great job. Thank you for this stage.
Okay, and I would like to thank all participants of this fight. This was a fantastic fight with very interesting presentations from all three teams. All three teams are fantastic, fantastic young scientists. They worked as teams and they have presented some of the most outstanding solutions to very challenging problems. So I think I can talk on behalf of all jury members that this was a great final fight and all participants are absolutely deserving to be called fantastic young minds and amazing scientists of the future. So congratulations to all teams, but we need to have the results of this fight, and there is no surprise that the results are already posted to the webpage and also to the text channel. But I will announce these results and we will also know what team has what medal of the IYNT. As you know, all finalists of the IYNT, any IYNT, are already the teams that have secured their silver or gold medal, but they compete for gold. And all teams that have the criterion of victory equal to 1 deserve the gold. Now we have some results and we can see what do we have in our fight. So one participant of this fight has earned 39.1 points and the criterion of victory equal to 0.5, 39.1 points and V equal to 0.5. Therefore, this team is the silver winner of the IYNT 2021 and we congratulate this team. This is the team New Zealand. Congratulations. The next team in our fight today has earned 42.5 points and V equal to 1, 42.5 points and V equal to 1. This team, therefore, is the gold winner of the IYNT 2021 and we congratulate Team Romania Limitless. Congratulations. Next team is the team that has earned the maximum sum of points in this final fight, 44.4 and V equal to 1, 44.4 points and V equal to 1. And this team, therefore, is not only the gold winner of the IYNT 2021, but also the absolute winner of the IYNT 2021, and this is the team Bulgaria. Congratulations all three teams. We are now 20 minutes behind the schedule, so we'll need to close this final fight now. I would like to thank everyone, and in just 20 minutes from now, let's start our closing ceremony. Thank you all jurors, thank you all teams, congratulations to all finalists and all participants of the IYNT. It was a great pleasure for me to be here with you in this final fight. Thank you and see you very soon.
We
Thank
also want to thank you for the outstanding science fight. It's really been a pleasure. Thank you.
Thank you very much. Thank you.
Thank you. All of you really deserve to be in the final. The degree of pressure was really high, and we were stricter with our marks. And so the discussions were very fruitful. All the performances throughout the tournament, especially New Zealand, who made a great comeback after the first science fight. So everything was really well deserved, and thank you guys.